kind of getting the shapes down, and that's okay. Now we're going to see where those shapes come from, and we're going to actually graph them a little more accurately and talk about their characteristics. So, he's got a beautiful little chart set up that you can fill in. Remember that sine is which coordinate? Y. So at pi over 6, you're just going to write down the y coordinate. And then at pi over 3, and so on, you're going to go all the way around the circle, writing down the y coordinates. And then once you get your little table filled in, let's start plotting the points. So at pi over 6, the sine is 1/2. He left 0 off. Let's start with 0 here. What is the sine at 0? 0, yeah, let's start with that. He left it out of our chart. Okay, at pi over 3, the sine is root 3 over 2, which decimally is what? I need to plot it, so I need to know what that is. 0.86, I think.
Yeah.
Is that right? So it's almost up to the top, not quite. How about a pi over 2? It is up at the top. And then 2 pi over 3 is the same as pi over 3. And 5 pi over 6 is the same as pi over 6. And then pi, we're back down. So there is yours looks better than mine because you've got actual spacing, correct? But there is your first half. Now, what happens beyond? Well, we're going to get the same decimal values, but now they're going to be down here. So we'll have -1/2, and that negative, that 0.8 number, -1, and then we'll be back at 0. So do you remember from when we did this a long, long time ago, that sine went through the origin? Now you know why. Because the sine of 0 is 0. The y coordinate is 0 there. Okay, beautiful. Could we keep going? Absolutely. The circle doesn't stop at 2 pi. We could go around again. But what would happen if we did that? We would get exactly the same thing. So this is a periodic function, and its period is 2 pi. All right, so we've already talked about period. Now we're going to talk about some other features of it. The midline. Obviously, the sine has a hill and a valley. Would you agree that that's the midline right there?
Yeah.
And in this case, the equation of the midline is y equals 0. In a minute, we're going to pick it up or drop it, and that's going to change the midline. Not the shape, but just the midline. It's y equals 0. Amplitude. Amplitude, by definition, is half the distance from the top to the bottom of the picture. That's the definition. I like to think about it as, how high are my hills? What is the height of my hill? 1. The amplitude is 1. Now, if we use the definition says half the distance from the top to the bottom. Well, -1 to 1 is 2, and half of 2 is 1.
Is the amplitude always positive?
Always positive. It's a distance, always positive. We already talked about period, and then we have frequency. Now, frequency is the reciprocal of the period. I'll explain that in a second, but for now, it's the reciprocal of the period. So for this, it would be 1 over 2 pi. Okay? You physics guys, when I turn on my car radio, do you guys remember what car radios even are? I don't know. Do you listen to car radios? Huh? Okay, well anyway, I just turn it off and the radio comes on. Sometimes I listen to AM stations. Guess what that A stands for? Amplitude. This is a sound wave, so it's amplitude modulation. And then guess what FM radio stands for? Frequency. That's adjustments to the frequency.
Does amplitude go farther than frequency? It's like,
Oh, I don't know. You'd have to ask the physics guys.
I know it does in like radio stations, but
Yeah.
like, I don't know about math. But
This next unit they go.
Now, amplitude deals with the size of the waves. Frequency deals with how close together they are, okay? So quickly over here, I'm gonna try to explain this notion of frequency. I'm gonna graph just a random old sine curve, and I'm gonna label this, let's say 1/2, 1, 3/2, 2. And then I'm gonna draw another one, random old sine curve, and this is gonna be 8, 16, 24, 32. All right? Now, what is the period of this guy right here? Now remember, period is how far we go before we start over again. So the period of this guy would be 16. The period of this guy would be 1. Okay, this is not gonna be a good example. Let me make that 1, 4, 1/2, 3, 4, 6. There we go. So now the period's 1/2. Do you agree with that? Frequency is how many periods, how many cycles you get done in an interval 1 unit long. So if I look at my graph and I look at 1 unit, frequency is a per unit thing. So 1 unit, how many periods do I get done in that 1 unit? 2. Frequency is 2. Period is how long it takes you to do a cycle. Frequency is how many cycles you get in 1 unit. So let's come up here. That's 1 unit right there. How many periods do I get done in a unit? 1/16 of the picture. Okay? Frequency is reciprocal of period. I mean, that's how you calculate it, period. It's reciprocal period. But that's what it means. How many cycles we get in 1 unit of length.
The period greater than 1 would always just be 1 over period.
It's always 1 over the period. Yeah.
Yeah, I just meant if it's less than 1.
Then it's still 1 over the period, but then it becomes a flip. Yeah. Yeah. It's always 1 over the period. Yeah, reciprocal of period. Okay, perfect. Next page. Do the same exact thing now with the cosine, would you? So fill in your chart, but this time you're going to fill it in with the x values. Would you agree? So you're going to fill in your x values. And graph it. get graphed already? Fast.
Works out a little bit.
Okay. Does yours look like mine? Is it the same picture? Basically, except what's happened. It's been shifted horizontally. But the shape is the same. All of the essential qualities are the same. So what is the amplitude? 1. What is the period? 2 pi. Where is the midline? Y equals 0. And of course your frequency is 1 over 2 pi. Does that make sense to you? The sine and the cosine are the same curve. They come from the same circle. We're just looking at different coordinates. Okay. So, we have this new word, sinusoidal. And a sinusoidal function is one that has the characteristics of a sine. Looks like a sine. So kids will sometimes say, is a cosine sinusoidal? And the answer is yes. Because if I looked at this part of the sine curve, or this part of the cosine curve, if I started looking right here, isn't that, if I extended it, isn't that a sine curve? Yeah, yep. Okay, so let's turn the page and look at example 1. 2 periods of something are shown. Find the period, frequency, amplitude, and midline for the graph. All right. 2 periods are shown. Can you tell me what the period is? Pi. Now, you don't have to count, because if they drew from 0 to 2 pi and said that's 2 periods, then pi has to be a period. So what's the frequency? 1 over pi. What's your midline this time? Y equals 3. And what's your amplitude? 3. Now, the midline and the amplitude will not be the same. It's coincidence this time. The amplitude is how high those hills are, and they happen to be 3. All right, number 2. What? No, amplitude is half the distance from the top to the bottom. Half the distance from the top to the bottom. How high are the hills? Just think of it as how high are the hills. The hills are 3 units high. Because the midline's 3. That's, it goes up 3 and down 3. Right? All right, number 2, what's happening? Several periods are shown. Find the period, frequency, and all this for this guy. What's our period here? Pi over 2. Pi over 2. Meaning the frequency is 2 over pi. Your midline this time is y equals 1. Isn't that the halfway mark between the bottom and the top? And if your midline is 1, then your amplitude is 2. Very good. Now number 3. Find the period, frequency, and amplitude of this thing. And they didn't draw a picture, but they gave you some important information. So go ahead with your partner, see if you can figure this out. So what they gave us was a max and then the consecutive min, right? And how far was that from the max to the min? Thinking of x, that was 2 pi. So does it make sense to you that to the next maximum would be another 2 pi? Because isn't the max to the min half of it? Okay, so if that would be another 2 pi, then the total would be 4 pi. So our period's 4 pi and our frequency's 1 over 4 pi. Now I just arbitrarily drew a midline in there, but if my high point's at 8 and my low point's at -2, then it seems like the middle would be the average of those. So 8 and -2 is 6. 3 is my midline, y equals 3. And then that makes my amplitude, if this is 3 and this is 8, then my amplitude is 5. Where this is going, you guys, you know the quiz that I just turned back? And you know, I had one of those, that was like a sine wave on it, right? The next time you see that problem, you're gonna be writing the equation of that curve. To write the equation, you need to figure all this stuff out and then plug in stuff into the equation. So that's where we're headed.
So are they always like, it's gonna be the same one, like from the
Absolutely, it's a sine curve. Yep, it's a sine curve. Oh, speaking of which, look what's next. We don't have time to do it, so we'll start on that next time.
And you gave me that folder. Oh shoot.
It's fine, just grab it from the bottom.
Everybody's got notes, everybody's got homework. I'm not assigning the homework yet, although you could do